Now that we have a good understanding of how ActiveSupport MessageVerifier works, it's finally time to implement the security layer in our TurboRails clone. So the objective here is to replace this article string with the signed version of it. And to do this, we're going to rely on ActiveSupport MessageVerifier. But to generate a new ActiveSupport MessageVerifier, we have to have a secret key. And so we are going to store this secret key in the TurboClone module. So what we're going to do is add some module methods here, and we are going to create an attribute reader called signed stream verifier key here that will be responsible to store the secret key, and we are also going to create the corresponding getter, and it will return the signed stream verifier key if it exists, and otherwise it will raise an argument error with the message turbo requires a signed stream verifier key to work properly. So now that we are able to get and set the secret key, we need to enable this key to be generated. And to do this, we're going to rely on two different options. The first option is that maybe the user wants to provide his own key. And if he doesn't, then we will generate automatically a key for him. So to do this, we're going to go in the engine and add a new initializer that we're going to call turbo signed stream verifier key. And what we're going to say is that we're going to set the signed stream verifier key here. So we're going to set it, and we're going to say that it's going to be equal to config turbo signed stream verifier key in case the user wants to provide his own key, and otherwise we're going to say Rails application key generator generate key, and we are going to pass basically the name of the key, and it's required for this generator to generate a key. So we're going to say turbo signed stream verifier key, but we could pass anything we want here. So this would work, except that in order to have access to this config.turbo option here, we have to declare it. And we are going to say that it is an ActiveSupport ordered options.new. So this is a very common pattern in Rails engines. If you're not familiar with the ActiveSupport ordered option object, I will add a link in the description, but basically it's a hash, but with a nicer syntax. As we can see, with the hash we would have those brackets here, and with an ActiveSupport order option we have like a method call. So all Rails engines have access to this config option here, and we are able to add keys and specify what they are. And if it is an ActiveSupport order options, then we can add some more keys to it, like in the hash. So if the user didn't provide us with a secret key, then we are able to generate one. So let's go ahead and test that it works as expected in the console. So what we're going to say is TurboClone signed stream verifier key, and as we can see, we generated automatically a key, so this works as expected. Now that we have a secret key, what we want to do is to be able to create a message verifier. So to do this, we're going to say signed stream verifier, and we're going to say that this signed stream verifier here is an ActiveSupport message verifier .new, and it takes as first argument the secret key that we just generated. It will take as the hash algorithm the SHA-256 algorithm, as it is basically more secure than the default SHA-1 algorithm, and the serializer will be JSON, as we saw in the previous video. So now that we have an ActiveSupport message verifier here, what we want to do is to use it to generate the signed version of this string here. So if we have a look at the streams helper, where the turbo stream from helper is defined, we can see that to generate a signed stream name, for now we're using the stream name from method. And what we want to do is basically to take the content of this stream name from method that we currently have and to sign it. So to do this, we are going to generate a new method. We're going to call it signed stream name, and it will take streamables as well. And what it's going to do basically is that we're going to use the stream verifier and we will generate a signed version of the string that we previously had. And to do this, we're just going to change the streams helper to use this method. So this should work as expected. I'm just going to restart the server to make sure that the changes are taken into account. And now when I refresh the page, I can see that I have a signed stream name here. So this works almost as expected, but now we are streaming from this kind of gibberish here. And previously we were streaming from the articles stream. So what we're going to do is go to the streams channel, and we are going to check if the signed stream name from the params is actually a valid signed string. If it is, we will kind of decode this string and stream from the verified value, and otherwise we will reject the connection. So to do this, we're going to say if verified stream name equals self.class verified stream name params signed stream name, and we don't have this method yet, but we're going to implement it right after. But in that case, we're going to stream from the verified stream name. So in our case, it will be the article string, and otherwise we will reject the connection. So let's implement this method here, and we're going to implement it right above the method that is responsible for signing the stream name. And this method will take a signed stream name as an argument, and it will use our message verifier, signed stream verifier, to verify the signed stream name. So with this method here, the gibberish that we have here is going to be verified by the ActiveSupport message verifier that we have here, and it will return the article string. If it has been tampered with, it will return nil. So that way we will be able to reject the connection. So let's refresh the page, and as we can see, we are streaming from articles just like before, and we are not streaming anymore from the gibberish. So this should work as expected. We're just going to perform a little test. So let's go inside the console here, and we are going to create an article. So we're going to say article create, and the content should be something here. And as we can see, the article was broadcasted as expected, and this time we have a signed stream name here that attackers cannot tamper with. So this is how the basic security is implemented in TurboRails by default. There's just one last thing that we need to do, and it is to basically run our tests to make sure that it works. And as we can see, there are 3 tests that are failing. They are all in the streams helper test. And if we have a look at the streams helper test, well, we can see that this is because the sign stream name here, it has been hard-coded, and we are going to need to use the sign stream name method that we have here. So what we're going to say is that we're going to say signed stream name is equal to turboclone streams channel sign stream name for articles, and then we can interpolate here the sign stream name. And we're going to do exactly the same thing for all the others tests. So here it's the article, and we're going to interpolate once again the sign stream name. And here we're going to say that sign stream name, it will take the articles as a first argument, the article string, and the article as a second argument, and we can also interpolate here the signed stream name. Let's go ahead and run our tests once again. And as we can see, our tests are green, our security layer is implemented, and so everything works as expected. In the next video, we will talk about creating rake tasks to install the TurboClone gem inside real Rails applications. But except from rake tasks, we just finished our Turbo Rails clone. It works exactly like the real Turbo Rails. We have security implemented, we have action cable, we have jobs, we have models, controllers. We were able to configure the engine successfully. So this is it. Our Turbo Rails clone is almost finalized.